So, hello everyone, and I'm back with another video today. And today I'm going to be explaining uh, this question called valid parenthesis. And what this question basically says is that we're given a string s that only has parenthesis characters in it. Alright, and we need to determine if this input string is valid. So, by valid, what they mean is that it should be a logical use of the parenthesis. So it can't be like a wrong use of the parenthesis. Like in this case, this won't be correct. Similarly, this isn't a correct use of parenthesis, right? But this is a correct use, and so is that. Uh, Great. What this means formally is that any opening bracket has to be closed by the same type of bracket. So a round bracket has to be closed by a round bracket only. It can't be closed by a curly bracket. Uh, like here, a square bracket is closing a round bracket, so this is not correct. And opening brackets must be closed in the correct order. So, so yeah, I guess that's pretty self-explanatory. And so that you can see that here. So here there's a round bracket and a square bracket. Now a square bracket has to be closed, be a closing bracket, right? But this round bracket is actually what's trying to close this square bracket, so that would also be wrong. So opening brackets have to be closed in the correct order, right? So that's all that there is to this question. Let's get into how to solve it now. So the way to solve this question is by using stacks. Uh, Now, what the algorithm is going to be is that we're just going to move through this string one character at a time, right? And whenever I'm at a character, I'm going to check what kind of character it is. So if it's an opening bracket, I'm just going to directly put it into my stack, right? Uh, if it's a closing bracket though, I'm not going to put it into my stack. Instead, what I'm going to do is I'm going to check the element at the top of my stack, and I'm going to see if the element at the top of my stack is of the same type uh, as this closing bracket that I have here. If it is of the same type, then I can pop this top element and carry on with the algorithm, right? But if it's of a different type, then I realize that uh, a different type of bracket is trying to close this uh, a different type of bracket. So there's a mismatch. That means I'll just have to return false directly, right? Uh, so we keep on going through the string like this. And another point is that once we've passed through the whole string, we're still not done. We have to check once again the stack, and we need to basically check if the stack is empty or not. So if the stack is empty, that means that all the brackets that had been opened have been also closed. But if it's not empty, that means some brackets haven't been closed yet. So again, we'll have to just return false if it's not empty. But if it's empty and it reaches outside the loop without breaking and returning false in the middle because of what I described before, then we can just return true, right? So here, let's just go through this example. So the first bracket is an opening curly bracket, so let's just put that into the stack, right? And yeah, so the second bracket is a round opening bracket, so we can put that into the stack too. Uh, then this third thing is a closing round bracket. So since it's a closing bracket, I'm going to peek at this stack. So I'm going to look at the top element, and I'm going to see if it's of the same type as of the element that I am at right now. I'm at a round bracket, and this is also a round bracket. So we're good. We can just pop this element off and continue add. Alright. The next element I encounter is a uh, curly opening bracket, so I'll just put it into my stack. The next element I encounter is a square open bracket, so I'll just put it into my stack. The next element I encounter is a closed square bracket, so I look at the top of my stack and check if this has an opening square bracket or not. So here it does have an opening square bracket, right? That means that we can just pop this element off because now these brackets have been closed. Then I look at the next element, so that's a closing curly bracket. So I look at the top of my stack and I see that this is a opening curly bracket, which is correct because this is the pair, right? So I can pop this one off too. And now I'll just go to my last element and see what bracket that is. So that's a curly closing bracket, and we look at the stack, we look at the top of the stack, that's a opening curly bracket. So these are of the same type and we can just pop this off too, right? Now once I'm done with this string traversal, I look at my stack again and check if it's empty or not. So this stack is empty definitely, and because it's empty I can just return true. So hopefully you guys understood how this works. Now we can get into the coding part of it. So the coding part isn't too tough. We can just make a dictionary first called correct. Okay, so this stores the correct pairs that should be encountered when I that it should check for when I encounter closing bracket. So uh, the closing bracket that I encounter will be my key, and the correct pair it should encounter will be my value. So like that, and the same for square brackets. This should be a closing one. I'm sorry. All right, and similarly for rounds. And that's all. Okay, and now I'm also going to need my stack that is going to be used, and that's all. So we can start traversing through the string now. So for character and string, yes, if this character is one of the opening brackets, yeah, so if this character is one of the opening brackets, then all I have to do is append it to the stack, right? And if it's not one of the opening brackets, then it has to be one of the closing brackets, because this is what we discussed before. Yeah, in that case, all I have to do is look at the top of the stack and compare it to the uh, element that this character that I have right now should have encountered, right? So the element that this character should have encountered is stored in correct, right? So I just have to look at the top of the stack and compare it to correct of ch, right? And if both of these are equal, that means the top of my stack has a correct conjugate for the current element, the current closing bracket that I'm at. That means that we're good. So we can just pop that element off from the stack, right? And if it's not the same, then I just have to directly return false, because I know that this it's messing up here. So definitely the entire string can't be valid. So I just have to return false. And yeah, here then I can just return. Oh, sorry. After the loop is executed, I'll just check if the length of the stack is equal to 0. Then I can return true. And if it's not, then I have to return false. Right. And a little thing that we missed here in this else part, that means if during our traversal through the string, if we encounter a closing bracket, I'm looking at the top element of the stack, right? I'm calling that top element of the stack. But what if the stack is empty? So this will throw an error, right? So I should just check if the length of stack is 0. Then just return false. And why am I returning false if the length of stack is 0? Because there isn't any opening bracket there, but we know that the element that we're currently at is a closing bracket. So this definitely corresponds to a wrong string S. Right. We can try running the code now. Great, so it works on this input. Let's just try submitting it. Alright, so yeah, it works, it passes, and although this shows that it's not that fast, this solution is actually only big O of n in time, so that's linear time complexity, because we're just passing through the string ones. And the space complexity is going to be big O of n too, right? Because we're using a stack here, so so the stack can become at most big O of like n times extra storage. Yeah, so that's basically it for today's video. So I hope this was helpful, and yeah, that's all. Bye bye.